All right, let's think about our solar system for a second. For 4.5 billion years, it's been this absolute masterpiece of cosmic clockwork. The planets move in these near-perfect, predictable circles, everyone keeping to their own lane, all held beautifully in place by a super delicate gravitational balance. We really like to think of our cosmic neighborhood as a safe haven, right? Like it's completely isolated from all the chaotic violence of the deep universe. But what if we imagined our fragile little glass house of a solar system suddenly coming face to face with a massive cosmic wrecking ball?
So what actually happens when that perfect clockwork we completely rely on for our very existence is suddenly shattered by an unstoppable intruder? Just imagine a massive gravity well cutting through the darkness straight toward us at 50 kilometers per second. What exactly happens to the planets, the asteroids, and to our own fragile home when this silent monster finally arrives?
Well, to really understand the destruction, we first need to know what we're actually dealing with here. Basically, a rogue planet is a wandering cosmic orphan. Back when a solar system is just forming, baby planets are packed really tightly together in what's essentially a celestial demolition derby. Sometimes two gas giants pass just a little too close, and in that crazy gravitational dance, one of them gets violently slung outward. It escapes its star's gravity entirely, and from then on, it becomes a rogue, just drifting through the freezing, pitch-black universe without a sun to warm it.
Now, here's the crucial point, and honestly, this number is just staggering. Billions. Astronomers actually estimate there could be more rogue planets in our Milky Way galaxy than there are stars. That literally means there are billions of these completely dark, invisible worlds drifting silently through interstellar space right now as we speak. And because they don't orbit a star, they aren't reflecting any bright sunlight, which makes them virtually invisible to our standard telescopes until it's way, way too late.
What makes this specific scenario so absolutely terrifying is this sheer scale. To put it into perspective, our intruder isn't just some wandering space rock. It boasts twice the mass and twice the physical radius of our own Jupiter. And because it's relatively young, it still holds on to its internal heat, making it an absolute gravitational powerhouse. It completely dwarfs our own massive protector, Jupiter, setting the stage for a clash that is honestly hard to even imagine.
So, how would this actually unfold? Let's track the monster's approach. It's traveling on a one-way hyperbolic trajectory, which just means it's moving way too fast to ever be trapped by the sun's gravity. It's cutting through our system at 50 kilometers per second. Now, space-based infrared telescopes would likely pick up its faint heat signature way out beyond Pluto. But as we track its path over decades, then years, months, and finally weeks, we'd basically be watching in horror as it systematically dismantles our outer planetary defenses one by one, long before it ever even reaches Earth.
Decades before this giant even passes a single major planet, its immense gravity awakens the Oort cloud. This is that vast sphere of icy debris balanced on a super-tight gravitational tightrope way at the edge of our system. The rogue acts like a giant cosmic rake, just sweeping through this field of ice, throwing millions of comets out of their stable orbits, and slinging a massive, deadly vanguard right inward. Down here on Earth, our night skies would light up with thousands of glowing comets. It would be a breathtaking, beautiful display, but really, it's a terrifying warning that the sky is literally falling.
As the intruder crosses the Kuiper Belt, shattering dwarf planets like Pluto everywhere, it reaches our very first major casualty, Neptune. And depending on the exact path, Neptune faces two pretty grim fates. It could get pulled into a highly elliptical, chaotic orbit, which would throw its entire climate into absolute turmoil. Or, and this is wild, the rogue could act as a slingshot, breaking Neptune's bond with the sun entirely and casting it out into deep space to become a rogue planet itself. Plus, Neptune's largest moon, Triton, would just be violently ripped away into the dark void.
Next in the line of destruction is Saturn. And, even if the rogue planet doesn't directly collide with Saturn, gravity is just a relentless force. The massive tidal forces from it simply passing by would completely tear apart Saturn's iconic glittering rings. Billions of tons of perfectly harmonized ice and rock would be stretched out into these chaotic, flowing streams. And worse yet, Saturn's potentially life-harboring moons, like Titan and Enceladus, would be fatally destabilized. It would either trigger massive eruptions of liquid water or just throw them into wildly unstable, doomed orbits.
Okay, this brings us to the ultimate cosmic showdown. Jupiter is our reigning king and longtime protector, boasting a mass 318 times that of Earth. It's been shielding us from dangerous debris for literally billions of years. But now it faces the ultimate heavyweight intruder, an object twice its size and mass. As these two colossal gravity wells draw close to each other,
we are set up to witness a gravitational battle of absolutely titanic proportions. When these giants pass each other, the tidal forces are just unimaginable. Huge strips of hydrogen gas get ripped from both atmospheres, creating this massive bridge across the vacuum of space. And if they happen to cross the Roche limit, which is that invisible boundary where tidal forces just pull a planet apart, it's not going to be a solid crash. It's a fluid, explosive merging that actually fuses them into a colossal, glowing brown dwarf. But hey, even a near miss slings Jupiter into a completely new orbit. Either way, this encounter permanently takes out the shield of our outer solar system. We are left totally exposed.
With Jupiter compromised, the rogue planet's gravity instantly scrambles the asteroid belt. It's exactly like a spoon vigorously stirring a massive bowl of soup. Hundreds of thousands of space rocks, some the size of entire cities, get sent hurtling toward the inner solar system. Mars happens to be the first terrestrial planet to face this relentless bombardment. Because its thin atmosphere offers zero protection, the planet is peppered by massive impacts that very quickly turn its red surface into a violent, molten sea. And just like that, our final barrier is gone.
Now, as the rogue planet finally arrives in the inner solar system, I want you to consider this massive multiplier, 600. We know our moon is responsible for the tides on Earth, right? Well, this rogue planet exerts over 600 times the gravitational pull of our moon. From down here, it would first appear as just a bright reddish star, but within weeks, it completely eclipses the full moon, casting this really strange, eerie crimson light across our entire sky.
But honestly, we wouldn't even have time to sit there and marvel at the swirling storm bands in our sky. The sheer physical trauma from that 600 times multiplier would already be tearing our world apart. Extreme tidal bulges pull the oceans miles back before unleashing mega tsunamis hundreds of meters tall that just swallow global coastlines. And it's not even just water. We get land tides, causing the solid earth beneath our feet to rise and fall by several meters every single day. All that immense friction shatters the crust, triggering supervolcanoes like Yellowstone and unleashing devastating magnitude 10 earthquakes all over the globe. As the rogue planet makes its absolute closest approach, the ruthless laws of orbital mechanics step in to dictate our final fate. We're essentially looking at 4 primary scenarios of doom here, and to be completely honest, none of them are pleasant, though they are undeniably spectacular. We've got the cosmic sling, the fire and ice orbit, being captured as a moon, or the ultimate collision. Let's do a rapid-fire breakdown of this climax.
All right, starting with scenario 1, the cosmic sling. This is where the rogue planet passes just behind Earth. Its gravity pulls us backward, dramatically slowing us down, and then violently slingshots us out of our stable orbit and away from the sun entirely. We actually become a frozen rogue planet ourselves. The oceans would freeze over within weeks. At that point, the only incredibly slim hope for human survival would be clustering around deep, dark ocean thermal vents or hiding in nuclear-powered underground bunkers.
Then there's scenario 2, the fire and ice orbit. Here, we actually stay bound to the sun, but our orbit is severely warped into a highly stretched elliptical trap. For half the year, Earth drifts way out past Mars into a global ice age, freezing solid. But then, as we swing rapidly back toward the sun, we pass incredibly close to the solar fire. The ice melts instantly, oceans boil, and temperatures soar way over 100 degrees Celsius. It's just this brutal, inescapable yearly cycle of freezing to death and then boiling alive.
Scenario 3 presents a really tragic irony. The massive gravity of the rogue captures us, so Earth survives, but only as a tiny moon orbiting the giant. Because we'd be so incredibly close to a planet twice Jupiter's mass, Earth would be constantly bombarded by radiation belts, thousands of times more lethal than what our magnetic field can handle. On top of that, extreme tidal heating would squeeze and stretch our planet constantly, boiling our oceans away and turning Earth into a sterilized, hypervolcanic hellscape, exactly like Jupiter's moon Io.
And finally, scenario 4, there is no near miss. It's a direct, ultimate collision. As Earth hits the massive gas giant's atmosphere at 50 kilometers per second, the friction is just instantaneous. Our atmosphere is completely ripped away in seconds. Earth heats to a white-hot glow, essentially burning up like a mere shooting star. Within minutes, our entire planet, along with literally all of human history, art, and memory, just dissolves into the crushing metallic hydrogen depths of the giant's core.
Now, because of its immense speed, the sun's gravity simply cannot hold on to the rogue planet. It steals our system's energy and just plunges right back into the dark interstellar void from which it came. But as this cosmic wrecking ball exits the scene, the aftermath is completely devastating. The delicate clockwork of 4 billion years is completely shattered. Planets are missing, orbits are violently warped, and our once perfect solar system is reduced to unrecognizable, chaotic ruins.
Okay, take a deep breath. As wild as all this sounds, the chances of this happening anytime soon are astronomically small. Space is wonderfully, unimaginably vast, but doing this explainer really gives us an incredible perspective, doesn't it? We live in a temporary oasis of stability. These conditions aren't permanent guarantees, they are absolute cosmic privileges. Thinking about this really instills a deep sense of cosmic gratitude for the steady warmth of our sun and the quiet stability of our beautiful, fragile blue planet.
Please like and subscribe.